I'm Santosh Eji. I'm honored to be here as a part of Desapex as a project engineer. So I extend a warm welcome to all of you to today's webinar, where we will explore into exciting topic called starting the digital twin journey for your facility. Firstly, we'll be seeing the agenda for today's. We'll be discussing about the history of digital twin. So its evolution across the evolution of the technology till today. Then we'll also be looking into what exactly is digital twin. Then we'll be looking into the difference between the BIM and digital twin. Also, we'll be talking about their both relationships. Then the versions of digital twin in the industry. Then necessity of having the digital twin. Then we'll be looking into the challenges that come across while the implementation of the digital twin. Then also basic challenges that can be solved, in AEC industry using digital twin. And as I said, the big question, how to start, where to begin, even this topic will be covered. And who must consider for having digital twin. The next thing is like a basic framework, you can say, or a prerequisites for implementation of the digital twin. So here we'll be speaking about both the existing and the new infrastructure projects. Next, we'll be speaking about the real case studies where the digital twin has been used and what is the outcome of their digital twin. Then also we'll be speaking about the benefits of digital twin and also the future aspect of digital twin. And the most interesting topic I can say, where we'll also be seeing what if digital twin collaborates with metaverse, what happens, what can be the outcome. We'll be seeing that. And last but not least, a Q&A session. So let's explore into the instances where the term digital twin was used, and let's examine the reasons behind its usage. So as we can see, past in 1960s, NASA engineers created the computer-based simulations, or you can call virtual representations of what it's like on a moon surface. So how it helped them? So it helped them understand the practice, the representations of what it's like on the moon surface. So it's like playing a video game to learn about the moon's environment and plan missions more effectively. So going back to 1970s, oil and gas firms adopt digital twins to enhance exploration. So they also created virtual replicas of underground reservoirs where they can analyze the data for more accurate drilling. Then in 1980s, the era of automotives. So automotive companies employed digital twins to streamline vehicle design and testing. They create virtual replicas of car and components, allowing engineers to simulate and refine designs before the car gets into the prototype or a build, a final product. And also the important thing, this technology, I mean the digital twin technology was used before, but it became well known in the 1990s. So when it was first mentioned in the book called Mirror Worlds. Then in 2000, the healthcare organizations also began to use the digital twins to manage their patient care. And back in 2002, so the concept and the model of digital twin was first publicly introduced in 2002 by Michael Griffiths at the Society of Manufacturing Engineers conference in Troy, Michigan. So as we can witness the inception of the digital twins era as it began in the past 1960s, and now look at its ongoing evolution across the diverse industries. Now, when we speak about 2021, we can see some of the world's largest owners. We talk about Amazon. They started using the digital twin, right? So the next thing, we'll see what exactly is digital twin. Is it just a 3D model or something more? So, well, let's look at its definition. So what does the definition says? Digital twin refers to a virtual representation of a physical building or an infrastructure project. This digital twin is created using advanced technology and data to replicate in the real world structure, allowing for a range of benefits throughout the project's lifecycle. So let's take an example and understand the definition in more understandable manner. So imagine you are building a new house. So with the digital twin, you can create a detailed digital copy of the house on a computer. You can use special technology and data to make sure it looks and behaves just like a real house. So how can this help? This can help you plan, design, manage the construction better, right? So you can also use this for testing things like how the heating and cooling systems will work before you actually build the house. It's like having a virtual blueprint that makes building easier and more efficient, right? So now let's talk about difference between BIM and digital twin. So just to add for this, so before I began my career at Desapex, BIM and digital twins were same for me. I thought they both are same, but now I have learned they are different, and I would like to discuss some of the distinctions. So these distinctions will be on certain important points or criteria, you can say. So the first one, we will discuss the purpose of both. So as we can see, BIM. BIM is a digital model of a building or an infrastructure project created during its design and construction stages. So BIM primarily deals with the static information, whereas a digital twin is like a live digital copy of a real building or a project. It includes design and construction information, but it's special because it also gets real-time updates from sensors and also IoT devices. Next thing, we'll be looking into the life cycle stage. So when it comes to BIM, so BIM usually focuses on projects early stages, like you say planning and construction. It helps architects, engineers, and contractors work together better for providing a shared digital space for coordination. So when it comes to digital twin, on the other hand, so it covers the entire life of infrastructure, say it from a design and construction to operation to the maintenance and even decommissioning. They give real-time insights into how assets behave and perform throughout their life cycle. And data and main focus. So when it comes to BIM, as we discussed in the earlier point, BIM is a static. It uses static data and usually doesn't include real-time updates. Its main focus is on ensuring design accuracy, or you can say detecting conflicts, estimating costs, and planning for construction. Whereas digital twin use real-time data from sources like sensors and IoT devices, enabling continuous monitoring, analysis, and optimization of assets or systems. Now, as we see some of the differences, now let's see the relationship between how they do each other, right? So BIM sets up the base for digital twins by providing detailed 3D model as an asset information. So it's like a basic step for having the digital twin. BIM deals with design and construction, whereas digital twins takes it further by adding real-time data and dynamic simulations for ongoing assets management, where BIM creates initial virtual asset, while digital twins provide continuous insights, analytics, and performance improvements, connecting the static design phase to dynamic operational monitoring. So next, now let's explore what are the different versions, you can say, or the types of digital twin. So the first one is digital twin prototype, DTP. What is DTP? So a DTP is a digital version of a physical item made before creating the actual product. So it helps simulate real life situations, saving money by predicting how the physical item will perform. So what are the advantages of this type of a digital twin? So it can be used in testing different scenarios before making the real thing. You take example of automotive industry, then understand how physical items behave in specific situations. Coming to its disadvantage, it needs a high accuracy and detailed data. Then where can be this type of a digital twin can be used? What are their application? So it can be used in automotive design and testing, creating a consumer product. So let's break down this type of a digital twin to understand it better with an example. Say a digital prototype of a car allows testing in various conditions like wind and terrain, ensuring it works well in those situations before making the actual car, right? So the next one is Digital twin instance, shortly called as DTI. So it is also a digital copy of a real object or system used to test how it behaves in different situations. So DTIs are made using data from sensors and other sources to monitor, simulate, and improve the physical counterparts performance. So what are the advantages of this? So this can be used in testing how a product works in a various situations, and also helps in understanding how the physical item will perform. So what are the disadvantages of this type of physical, digital twin? It also requires an accurate and a current data, right? So applications, you can use this type of a digital twin in maintaining industrial plants, advancing healthcare technology, managing smart buildings. For example, an industrial plant's DTI can track production, find the bottlenecks in the earlier and enhance the efficiency. It can also predict how the system responds to the changes like weather, or you may call traffic, aiding engineers in making better decisions. So the next one is digital twin aggregate, also called as connected digital twin. So what is connected digital twin? So this is a collection of digital twin instances connected to share and analyze real-time data. So DTAs are useful for monitoring large complex systems like power grids or transportation networks. So we can say advantages of this type of digital twin is like monitoring, using this digital twin for monitoring the complex systems in the real time, where it helps in understanding the performance of different system parts. So when we see its disadvantage, it also requires accurate and current data from all digital twin instances. So applications maybe, as we just discussed, it can be used in monitoring power grids, managing the transportation networks, planning the smart cities. So as we can see from all these three type or three versions of this digital twin, so one disadvantages was it requires a current, or you can say accurate data. So we can say if data is accurate, the efficiency of using the digital will be more, right? Yes. So in the next part, we shall discuss what is the necessity for having digital twin. Why one project owner or an infrastructure project owner should have a digital twin. So seeing the first point, digital twins provide precise virtual project models, helping architects and engineers identify pre-construction problems, simulate scenarios, and make informed decisions. Let's break down this point using, for instance, a digital twin can simulate different weather conditions, traffic loads to optimize its. The next point, digital twins promote collaboration. When designing a new office building, so there are like several team members, or you can call several stakeholders, uh, where they use the digital twin to view and discuss the design in real time. This reduces misunderstandings. So this also improves efficiency and minimizes design and construction errors. The next point, digital twins help and fix design problems earlier. How? For example, now let's take an example of designing a new car. So a digital twin can simulate crashes and performance to ensure safety and efficiency before building physical prototypes. Next, by integrating real-time data from sensors and IoT devices into digital twins, projects can be continuously monitored for performance and condition. So, for instance, in a smart building, digital twins can use data from various data sources like sensors to detect the temperature fluctuations and adjust the HVAC system for energy efficiency in real time. Then digital twins promote sustainability. How? In a constructing a green building, a digital twin can simulate various materials and designs to optimize energy efficiency and minimize environmental impact, making the building more eco-friendly, right? So next point, digital twins are not just useful during construction, but also for facility management. How, for example, a digital twin of a hospital can help facility managers track the condition of the equipment, plan the maintenance period, and optimize the layouts for efficiency in the patient care. Next, digital twins provide a complete picture of project's life. For example, let's take the example of a bridge construction. So in this construction project, a digital twin can track the bridge's condition over time, helping the engineers decide whether and when and how to perform maintenance, ultimately extending its life, right? So the last point, digital twins empower AEC industry. So for instance, in building a new skyscraper, a digital twin can collect and analyze data on materials, construction processes, and energy efficiency, enabling architects and engineers to optimize design and construction for better quality and sustainability. So coming to the next topic, so far we have discussed about digital twin technology, including its various types, why it is important, etc. So however, when it comes for actual implementation of a digital twins for a project, there are challenges, right? We need to address and ways to overcome them. So now we shall be seeing what are the challenges one by one. So the first one is data integration and standardization. So what is the challenge here? So collecting and combining data from various sources like BIM models, IoT sensors, old systems, and manual records can be quite complicated. So how can we overcome it? Tackle the problem of integrating data from different sources in digital twins. You can establish data and a central system. So let's take an example. Imagine we have a big construction project where it is using the digital twins. So you are getting data from different sources like 3D models, weather sensors, equipment sensors. To make things work smoothly, so you create rules for how the data should look. You can say naming all the measurements the same way, so the computer understands it. You also set up clear instructions for how the data should move between systems, like sending temperature data every 5 minutes, right? So finally, you can create a central place like a cloud or a server where all the things goes there. So this makes it easy to check the construction progress, monitor weather conditions, and ensure everything is on track. Next, complexity and scalability. So what is the challenge? AEC projects come in various sizes, right? And also the complexities. So making it hard to create digital twins that can easily grow or adapt. So how to overcome this? Employ versatile digital twin systems that can be customized for different project needs. So for example, imagine you are working on a two construction projects. So one involves, you can say, a small office, and the other one includes a massive skyscraper. So with a flexible digital twin platform, you can adjust the level of detail and features to match each project. For instance, when you talk about the small office, we might focus on basic monitoring, while for the big building or skyscraper, you can incorporate advanced simulations and data analysis. So this adaptability ensures that your digital twins suit projects for various sizes and complexities. Next, a very important point, that is cost and investment challenge. So what is the challenge? So creating and managing a digital twin infrastructure can be expensive. So involving investments in technology, software, and training. So how to overcome this? Create a compelling business plan with the long term, where we should also discuss about the long term advantages and explore collaboration to share expenses. So let's say you are in a charge of cities infrastructure management. This is an example. So you want to implement digital twin for better maintenance. So what we do initially, there's a cost for technology, software, and training your team well need. So to address this challenge, you develop a business case that shows how digital twins can reduce maintenance costs over time by predicting when repairs are needed. You also explore partnerships with neighboring cities to share the initial expenses of setting up the digital twin. The next point, data privacy and security. So protecting sensitive project data, especially in a collaborative environments, while compiling with privacy regulations. The solution is, we need to implement a robust cyber security measures across, measures, access controls, and data encryption to safeguard the information. Next, interoperability. So what is the challenge? So making sure that digital twin technologies and software can easily talk to each other and share information. So how to overcome this? Let's take an example and discuss. So think about a manufacturing company that uses various machines and software to control production. So to address interoperability challenges, they invest in digital twins for each machine. This ensures that all these digital twins use software that follows open industry standards, allowing them to easily exchange data and work together. This enables the machines to collaborate more efficiently, one thing, and it also improves the production process and also reduces the downtime. Next one is skill gap. So a shortage of professionals with expertise in digital twin technology and data analysis. How can we overcome this? Obviously by investing in their programs, training programs, you know, and collaborating with educational institutions to bridge skill gap. Next, change management. So facing a resistance to implementing a new technology and workflows in ASA organizations. For example, if there is an infrastructure or a manufacturing firm, so they will be following old methods. So when you introduce a new type of technology, that could be difficult for them to change suddenly. So how this transition should happen? Let's take an example. So imagine a construction company wants to introduce digital twins to streamline project management. Some employees may resist the change because they're used to traditional methods, as I said. So to address this challenge, the company develops a change management plan. They hold training sessions to teach employees how digital twins will make their work easier and more efficient, emphasizing benefits like reduced errors and faster decision making. Next, data quality and accuracy. The challenge is making sure that the data used to create and update digital twin is correct and dependable. So as we discussed, you know, during the versions of digital twin, one disadvantage of digital twin of all this digital twin was like data accuracy, right? So how can we work on this? So let's say, we are using a digital twin to monitor a water treatment plant. So to deal with the data accuracy challenges, you set up a system to validate the data collected by sensors, and also you schedule regular sensor calibration to ensure they provide accurate measurements. Additionally, you can use high quality data capture methods like you say a water quality testing equipment to maintain data accuracy and reliability. This ensures that the digital twin accurately represents the conditions of water treatment process and enables better decision making for the plant's operations. Next, complexity and visualization and analysis. So what is the challenge? Effectively dealing with a large amount of data linked to the digital twins and making it understandable. So this is the main challenge. So consider, a smart city project that employs digital twin to monitor various aspects like you say traffic, and you can take example of energy usage and air quality. To address this challenge of handling complex data, you implement powerful visualization software, analytics platforms, etc. These tools helps you transform the data into clear and actionable insights. This is very important, right? Like yes, enabling cities officials to make informed decisions about traffic management, energy conservation, and pollution control. Next is resource constraints. So the challenge is like limited resource. You may say it has a budget or a personal. A person is nothing but a skilled person to use that digital twin. Can hinder adaptation of digital twins. So how we overcome this? So let's take an example. Imagine, you are working in a municipal government. So you are interested in implementing digital twins for infrastructure management. So due to budget constraints, you cannot tackle all projects simultaneously. To overcome this challenge, so we need to prioritize projects based on their expected benefits and ROI, return of investment. For example, you might start with a digital twin for cities water distribution system because it offers significant potential cost savings through improved maintenance. Additionally, you can explore cost-effective ways to develop the digital twin, such as leveraging existing data and collaborating with the neighboring municipalities to share the resources. So next, we will be seeing into some of the challenges which can be solved using, by implementing the digital twin. So the first thing we see design and visualization. So how? For example, And suppose you are working a new architecture project, like designing a modern building with intricate details. Traditional 2D drawings may not effectively convey the design complexity, right? So by using a digital twin, we can create a highly detailed 3D model that provides a realistic representation of building. This allows all stakeholders, including architects, clients, and contractors, to easily visualize and understand the design elements, making it simpler to make informed decisions and ensure that the final construction aligns with the initial version. Well, the next thing, collaboration and coordination. So, what is the challenge here? Like coordinating work between architects, engineers, contractors, and stakeholders can result in miscommunication and delays. So, for example, consider a large construction project. As you know, there will be a lot of multiple teams, or you can say multiple stakeholders who will be working. So, without a digital twin, different teams might use separate plans and blueprints. So, this will lead to confusion and delays. So, by implementing digital twin, in that situation or in that project, all stakeholders can access a centralized virtual model. So architects, engineers, and contractors can collaborate in real time, ensuring everyone is on the same page. So this minimizes errors, right? Streamlined communication can happen and keeps the project on schedule. Next, class detection. So let's take an example here. Imagine we are constructing a new office building. So in the past, discovering a design clashes like a pipe running through a wall often happen during construction. So which is leading to costly revisions, right? Also a time consuming. So with the digital twin, you create a 3D model of an entire project. During the design phase, the software can automatically identify clashes, allowing you to adjust the plans before construction begins. Cost estimations and optimization. So in an instance, when planning a new infrastructure project, like consider a highway expansion, so project managers often encounter unexpected cost overruns. So with the digital twin, they can create a virtual model of the project and use it to estimate costs more accurately. Additionally, they can run various scenarios to analyze different construction methods and materials where they can find the most cost effective solution. This data driven approach helps optimize the project budget, right? And also it ensures it stays on track within the financial constraints. Real time monitoring. So what is the challenge that got solved here? Like tracking construction progress and performance in real time can be difficult. So what was the solution? So after implementation of the digital twins, IoTs and digital twins, one can get the real time data, so which also enables the project or the different stakeholders to take a data based decision making. Next is predictive maintenance, a very important point, right? Like yes, so maintaining infrastructure and buildings effectively can be expensive and reactive. So example, in a manufacturing plant, machinery breakdowns can lead to a costly downtime. So digital twins can monitor the equipment's performance using real-time data from sensors. By analyzing this data, the system can predict when a machine is likely to fail and schedule maintenance proactively. So this prevents unexpected breakdowns, reduces downtime, and extends the machine's operational life. So and also significantly resulting in significant cost savings and increased productivity. Next, energy efficiency and sustainability. So digital twins simulate the impact of design and operational changes on energy consumption and environmental performance, adding in sustainable design and operation. Next, facility management. So in an hospital, let's take an example. So when we consider a hospital, managing various systems like HVAC, you may say electrical or medical equipment can be complex. So digital twins create a detailed virtual representation of the facilities, allowing facility managers to monitor the condition and performance of all the systems in real time. So this helps in planning maintenance, ensuring all equipment operates efficiently, optimizing the allocation of space for patient care. Risk mitigation, the next point. So the challenge here was recognizing and reducing risks during construction and operation is vital. So solution is like digital twins assist in analyzing and forecasting potential risks, allowing proactive steps to mitigate safety and operational concerns. The next thing is regulatory compliance. What was the challenge? Meeting regulatory requirements and documentation can be time consuming, right? So the solution is like implement the digital twins where everything will be automate, like everything will be can be automate compliance, monitoring and documentation. So this will reduce administrative burdens. Next, the big question. Right now we all saw what is digital twin, its users, and now the question comes around, right? Like how and where to start. So we'll see like point by point. So the first thing is like purpose or objective. So what are the primary aims and goals you have in mind when creating a digital twin? Example, when creating a digital twin for a new city infrastructure project, so what are the specific goals you have in your mind? For instance, are you looking to improve traffic management, or you want to optimize energy usage or enhance disaster preparedness? Next, object of interest. So what particular object, or you may call a system or environment, are you focusing on when creating a digital twin? So in a manufacturing plant, when we talk about, so what specific machine or a production line are you targeting to develop a digital twin for? Next, LOD, that is level of detail. So are you aiming for high level of overview or a highly detailed representation when creating a digital twin? So example, when designing a digital twin for a residential building, do you want a basic overview of its layout and systems, or do you want an intricate detailed model that includes every aspect of the structure and its operations? This is data integration. So are you planning to incorporate various data, say like CAD models, technical specifications, sensor data, and IoT data into the digital twin? So, example, like when developing a digital twin for a smart manufacturing facility, do you intend to integrate CAD drawings or technical manuals, real-time sensor data from machinery, and also IoT device information into the model to create a comprehensive representation of that facility operations? Next, visualization. So how do you intend to visualize your digital twin? You can say a first person perspective or a third person perspective, or you want to use VR or another approach. For example, when presenting a digital twin of an urban development project, are you planning to offer a first person experience that allows all stakeholders virtually walk through the environment, a third person view for all for an overall perspective, or perhaps incorporate VR technology for an immersive experience? So these are the questions one should ask or discuss before he wants to implement digital twin for his project. So the next one is interactivity. So do you require users to interact with the digital twin? And if so, what type of interactions are you looking to enable? So let's say you are creating a digital twin for a smart home. So do you want homeowners to interact with the digital twin through their mobile applications, where allowing them to adjust lighting, temperature, and security settings in the real time? Next is data presentation. Like what type of data you intend to link with the digital twin? Are you looking to incorporate technical information, performance metrics, maintenance history, or specific data categories? So in a context of digital twin for an industrial machine, you plan, like you want to associate technical specifications, real-time performance metrics, maintenance history of those machines or records, and safety information with that model for comprehensive monitoring and analysis. Next is real-time data. So are you planning to incorporate real-time data into the digital twin, such as the sources of sensors and also the data from IoT devices? Integration with existing system. So do you want to do you require your digital twin to integrate or like collaborate with your existing any of the existing softwares or systems within your organization? So for example, in a manufacturing facility, do you want a digital twin to seamlessly integrate with your existing enterprise resource planning, that is ERP system, to ensure synchronized production planning and inventory management? Next, very important, security and privacy. So do you have any specific security or privacy concerns regarding the data or information utilized in the digital twin? So if we consider an example, in a research laboratory, conducting experiments involves private technology. So is there a need to ensure that the data and information used in the digital twin remain highly secure to prevent any intellectual property theft or unauthorized access? And also some of the important points like to account for the changes of revisions. It may be a monthly or quarterly, depending upon the project milestone. And also end user requirement. This is really important. Like, who are the main users of the digital twin, and what are their distinct needs and expectations? So, for example, for a manufacturing company implementing a digital twin for quality control, so who are the primary users? Obviously, the quality assurance teams. So, what are the specific requirements, such as do they want to access the real-time production data, statistical analysis tools, and alert notification to ensure product quality meets industry standards? So, who must consider for having the digital twin? So, we here at Desapex provide these digital twin services and their implementations for various diverse industries. So, let's see one by one. So, the first one, hotels and restaurants, how they can benefit. Just to take a scenario, a restaurant can use a digital twin to evaluate table arrangements and staff placements, so guaranteeing a more seamless dining experience for customers. Second, real estate management. Say an example, a company might employ a digital twin to recognize office spaces, allowing for a greater flexibility in remote work arrangements. Then residential users, for instance, house owners can virtually test furniture and lighting arrangements to enhance both efficiency and aesthetics. Next, airports harness the power of digital twins to enhance operations and passenger satisfaction. These virtual representations optimize various activities, predict and mitigate congestion, streamline security procedures, and improve gate assignments. Next, data centers. So they provide real-time monitoring for server racks, cooling systems, power efficiency. Through simulations, administrators can optimize server placements, enhance cooling strategies, and predict maintenance needs. Going to the next point, rail and metro. So digital twins are valuable for rail and metro systems as they generate virtual replicas of tracks, trains, and stations. So they assist in real-time monitoring, predictive maintenance, and enhancing operational efficiency. As we go on, it can also be used in logistic and warehouses, in the manufacturing industries, retail industries, and infrastructure management. So let's begin by exploring the necessity requirement for implementing digital twin. So whether it's for brand new project or for existing ones. So what are the basic steps, or if you say prerequisites for for the implementation of digital twins? So firstly, we'll be seeing about the new projects. So the first point is clarity, right? Like, what is clarity? What does clarity say? So establish a clear objectives for creating a digital twin. So defining it desired results and providing direction for its development. Identify precise use cases to ensure purposeful implementation. Next, holistic. So before embarking on a new construction project, it is essential to have a comprehensive architectural and engineering design plans. These plans should include detailed 3D and 2D and 3D drawings, floor plans, elevations, sections, and all relevant design documents. Next, a very important thing, a BIM model. So it serves as a digital representation of a building, encompassing its structure, materials, systems, and crucial information. So it's a crucial to establish this foundational BIM to meet our essential requirements. Next, spatial. So if you want your digital twin to be like a more realistic, so what you do, like we collect a precise geospatial data from the construction site encompassing topography, or you say soil details and geographic coordinates. This data is vital for ensuring accurate placement and alignment of the building. Next, scheduling. So create a well-defined construction plan and a timeline for the project. This plan should outline project milestones, provide the timelines for each construction phase, allocate the necessary resources accordingly. Next, IoT system. So to enable real-time monitoring within your digital twin, it is very essential to have a IoT sensors and a robust data infrastructure in place. So these sensors will track critical data such as temperature, occupancy, energy consumption, providing valuable insights. Next, we will focus on the prerequisites for existing projects. The first point, as it's common, the clarity, as we discussed, in a previous slide. So, what are the clear objectives for creating the digital twin, defining the desired results, and providing the direction for its development? Next, blueprint. What is blueprint? So, creating a robust digital twin begins with having a comprehensive architectural and engineering design blueprints, which serve as a foundation for building initial 3D model. Yes, BIM. So, as we discussed in a previous slide, a BIM plays very useful role and also a foundational step before having, before implementation of the digital twin. So it is crucial to first establish this foundational BIM to meet our essential requirements. Then precision. So what does precision talks about? So when dealing with existing buildings, obtaining accurate as-built data is crucial. So this ensures that digital twin accurately reflects the current structure. How can we achieve this? This often involves methods like laser scanning or surveys for precise measurements. Next is IoT system. So to enable time monitoring within your digital twin, it is essential to have IoT sensors and also a robust data infrastructure in a place. Next, fusion. So what is fusion? Like to create an efficient digital twin, formulate a strategy for seamless integrating data from various sources. We may say like including BIM, sensors, GIS data, or historical records. This integration plan guarantees comprehensive access to the data for well-rounded presentation. Moving further, we will be discussing some of the common, points for both of the projects. That is like new project or the existing project. These are the common things. So the first thing we'll talk about collaboration. So efficient collaboration among stakeholders, including architects, engineers, contractors, and facility managers, is of utmost importance. Clear communication and coordinated efforts are essential for successful development and utilization of digital twin. The next thing is twin tech. What is twin tech? So we need to choose and deploy the suitable digital twin platform or software that aligns with the project's objectives and needs. Also, we need to ensure that a selected platform supports essential functionalities such as data integration, visualization, and analytics capabilities. The next point is info security privacy. So what is this? So to make our digital twin information secure and to build that privacy, so we need to put in a place a cyber like strong cyber security measures to safeguard the data and systems of the digital twin. So ensure compliance with the data privacy regulations to protect sensitive information effectively. Next is like skills development. So make certain that the team members starts participating in the digital twin project processes that require skills and receive appropriate training to proficiently develop, operate, and unkeep the digital twin. Budget and resources. So we need to allocate the essential budget and resource to support the development and ongoing maintenance of the digital twin. So this allocation should cover all kind of costs related to the technology, software, sensors, and personnel involved in the project. Then a transition strategy. So if they are using any old methods in the manufacturing industry, the transition between the new technology may be difficult, right? Like create what we can do, create a change management plan, facilitate adaptation of a digital twin within your organization, so that we can ensure that stakeholders are adequately prepared for the transition and provide the necessary support and guidance throughout the process. Next, as I said, we'll be looking into case studies where they have used digital twin or you can say they implemented the digital twin, and what were their outcomes. So first case study, we'll talk about KIA, here that is Kempegowda International Airport. So first we'll see an overview. So as we know, Kempegowda International Airport, situated in Bengaluru, stands as one of the India's busiest and most notable airports. In response to the growing demands of contemporary air travel, the airport management initiated a groundbreaking project to introduce a digital twin for enhancing airport operations. So now let's see about objectives. Like what were their objectives? So they wanted to they wanted enhancing passenger experience. They wanted to enhance the passenger experience. How? By reducing the wait times, security issues, improving overall passenger certification, and also they wanted improve their security by closely monitoring passenger movements and potential security threats. Then optimizing operational efficiency, streamlining daily operations. It may include passenger flow, staff allocation, baggage handling for improved efficiency. So what were their implementations? So the first thing is data integration. Kia seamlessly integrated data from diverse sources, we can say, including security cameras, passenger flow sensors, baggage handling systems, access control systems. So this data served as the basis for constructing a comprehensive digital twin of the airport operations. Then the second point, real-time data collection. So the airport deployed sensors and cameras across the terminal to continuously collect real-time data on passenger movements, or you can say a security checkpoints, baggage handling. So this live data stream was consistently fed into the digital twin. 3D modeling. So leveraging the gathered data, a detailed 3D model of the airport facility was generated within the digital twin. This model accurately replicated the airport's layout, encompassing terminal gates, security checkpoints, baggage handling areas. So after implementation of all this, how Kia led to a valuable uses. So they got no, there was an advantage for them in a real-time passenger workflow monitoring. You can say, enhanced security in terms of baggage handling optimization or scenario planning. So this was all about a Kempegowda International Airport uh, when they implemented a digital twin for their infrastructure project. Next, we'll be seeing into a different scenario where a city, a big city of India, that is Pune, how they implemented a digital twin and for like what was the reason. So a overview, as we know, Pune is one of India's rapidly growing urban areas. Recognize the need for advanced urban planning and development solutions. To address this, the city embarked on groundbreaking digital twin project. So what were their objectives? What they wanted to solve? So the first one is a dynamic 3D model. So to develop an interactive 3D model for real-time urban insights, resource optimization, allocate resources efficiently, aiding infrastructure and traffic management. Urban governance. So they wanted to enhance governance with data-driven insights and planning tools. So how they implemented? So the first thing we can see, the geospatial data collection. So geospatial data, including satellite imagery, LiDAR sensors, and GIS data, was collected to create a 3D representation of the city. These data formed the foundation of the digital twin. Next, IoT sensor deployment. So these IoT sensors were strategically placed throughout the city to monitor various parameters in the real life. So this included traffic workflow, traffic flow, their use cases. So they got benefited in traffic management, real-time monitoring, monitored traffic flow and congestion in real time. So optimized traffic signals, used the insights of traffic signal timings and reduce. They were able to reduce the congestion. Second one was urban development. How by visualizing the impact. Then alignment with the master plan. So they ensured that new developments aligned with the city's master plan. Emergency response. So like emergency response, like disaster simulation. So they simulated disaster scenarios for effective evacuation and response plan. So this was all about the two case studies where the implementation of digital twin was happened, and we also saw the overcome, like the product of that. Next, we will be speaking about the benefits and the future of digital twin. So we will be speaking or taking points in diverse industries, not only construction industry, but various industries, how the digital twin can be benefited and what are the future aspects of that. So when it comes to construction industry, digital twins are essential in construction which can improve design and project management. They create detailed virtual replicas of projects, enhancing planning and resource allocation. Next is retail. So retailers use digital twins to optimize store layouts, improving customer experiences and sales. Next is logistics. So digital twins enhance supply chain management, tracking goods and predicting delivery times accurately. In automotive industries, so car manufacturers employ digital twins for vehicle design. It may be used for testing and predictive maintenance, like you can take an example of Tesla's simulation of autonomous driving scenarios. And environment. So environmental agencies use digital twins to model and monitor ecosystems, aiding in conservation efforts. Example, monitoring coral reefs for conservation. Then next is manufacturing. So digital twins optimize production lines, like General Electric, that is GE's use of digital twins for jet engine production, reducing maintenance costs and downtime. So let's take an example here in a predictive maintenance. So in a manufacturing industry, so digital twins are employed for a predictive maintenance by creating virtual replicas of physical machinery or systems. These twins continuously collect real-time data from sensors, IoT devices to monitor equipment performance. Data analytics and machine learning algorithms, they can also predict when maintenance is needed. For instance, if a digital twin of a CNC machine detects abnormal vibrations or you say temperature spikes, it can alert maintenance teams to schedule repairs before a breakdown occurs. So minimizing downtime and optimizing the production efficiency. Next, healthcare. So in healthcare, digital twins personalized treatments. Example, simulating a patient's heart for precise surgery planning. Smart cities, the best example just now we had from case study from Pune. So smart cities and urban. City planners use digital twins to enhance urban infrastructure, like Singapore's digital twin for traffic management. Then aerospace industries. So as we were discussing about the evolution of digital twin, how digital twin was used in NASA. So in aerospace, Airbus employs digital twins to monitor and improve aircraft performance, reducing fuel consumption. Next, energy. So utility companies create digital twins of power grids for real-time monitoring and fault prediction, ensuring reliable energy supply. So example, by combining digital twins with AI and algorithm, enhances predictive capabilities of systems like uh, wind turbines. Like if you take a wind turbine as an example, for example, in the case of wind turbine, when we talk about data collection, sensors on the physical turbine collect data on a wind speed, direction, blade angle, and more, feeding this information into digital twin. So the digital twin replicates the wind turbine in a virtual environment and continually updates itself with the real-time data from physical turbine. And when we start integrating the AI algorithms, where we can analyze historical data along with the real-time inputs to identify patterns and corrections. For instance, they may notice that a specific wind speed or you can say and a blade angle combination tends to result in optimal energy production. And also predictive maintenance, as I spoke just now, and predictive energy production. So using AI, the digital twin can forecast future energy production based on weather forecasts and historical data. So if it predicts strong winds, it can anticipate higher energy generation and help grid operators plan accordingly. So the next comes the interesting topics. So what happens a digital twin and like it gets collaborated with the metaverse. So we'll be taking an example of construction industry. What happens if a construction industry's digital twins get collaborated with metaverse? So imagine a construction company using a digital twin integrated with metaverse for a large scale building. So the first thing is remote collaboration. Project stakeholders, such as architects, engineers, construction managers, and clients can utilize VR headsets or augmented reality devices to access virtual construction site. They can collaborate in real time, discussing design modification, reviewing project advancements, and making decisions within the metaverse. Next thing, simulation and safety. So construction workers use the metaverse to simulate tasks and safety scenarios, identifying hazards and enhancing safety measures before physical construction begins. Next, supply chain optimization. So the digital twin combined with the real-time data monitors the availability and delivers status of construction materials. So prompt action can be taken to address delays or issues, preventing project setbacks. Next is project visualization. So clients and investors can take a virtual tour of the construction site, gaining more insight into the project's final outcome even before the physical work commences. Next, progress monitoring. So the digital twin continuously updates the construction progress, enabling stakeholders to more effectively oversee and manage the project's time and timeline and budget. Quality control. The digital twin equipped with advanced sensors and AI continuously monitor quality in real time, so detecting defects or deviations from design specifications. Then maintenance and life cycle management, which is very important. So beyond construction, the digital twin remains a valuable asset for facility management, as we discussed before. It assists in tasks like maintenance, repairs, and renovations throughout the building's life cycle. So this was all about the combination of digital twin and a metaverse in a construction industry. Next, we will see what happens, a digital twin when combines with the metaverse in a healthcare industry, right? So imagine a healthcare facility using digital twin technology integrated with metaverse for patient care and medical training. First is patient consultations. So healthcare professionals can conduct virtual patient consultations within the metaverse using VR headsets or use augmented reality. They access medical records, discuss treatment options, and visualize patient's anatomy in 3D for more comprehensive discussions. Next, medical training. So medical students and professionals can utilize the metaverse for realistic medical training simulations. For example, they can practice surgical procedures, diagnose virtual patients, and their skills in a safe and controlled environment. Remote surgery assistance. So surgeons conduct complex surgeries with the aid of digital twins and metaverse technology. Experts from across the globe collaborate in a real time, providing guidance and insights during the surgical procedures. So best example we can relate in this is like back in COVID, like back in the time of COVID. So we can say like surgeons can have the meeting in a metaverse and they can discuss the solutions, better solutions for the betterment of the world, right? Then telemedicine. So patients can have virtual appointments with healthcare providers from their homes. Doctor utilize the digital twin to visually show patients their conditions and real-time monitoring. Hospitalized patients can receive real-time monitoring through IoT sensors and data integrated into the digital twin. So medical staff can promptly respond to the changes in vital signs, emergency situations, ensuring patient safety. Then resource management. So hospital administrators can optimize resource allocation by analyzing data from the digital twin. This includes managing bed availability, equipment utilization, and staff scheduling. Next, emergency preparedness. So hospitals can use metaverse to simulate and prepare for the diverse emergency scenarios, including mass casualty incidents or disease outbreaks. Best example is again the COVID-19 situation. So this aids in staff training and the enhancement of emergency response protocols. Next, research and development. So medical researchers or medical students utilize the digital twin to conduct different experiments where they can analyze patients' data and collaborate on advanced medical endeavors. So this was all about, in this webinar, we delved into the history of, and you can say the development of digital twin technology from 1960s onwards. We also discussed what digital twins are and how they are used across different industries, like you say construction industry, healthcare industry, retail, and urban planning. We also talked about how individuals and organizations can start their own digital twin projects, whether for new buildings or existing ones. Additionally, we touched on the fundamental structure, or you can say structure or a prerequisites of a digital twins and their potential connections with futuristic concepts like metaverse. So, if you have any questions about the topics we have discussed about so far, so please feel free to ask. So, thank you for joining us on this exciting journey of building a digital twin for your facility. If you have any questions or need clarification of any of the topics we have discussed in the webinar, please don't feel hesitate to reach out through us, from various platforms like LinkedIn, our website, or email address. And once again, I would like to express my heartfelt gratitude to all of the attendees for joining us in this informative session. Your participation and interests are greatly appreciated. Thank you for being a part of this engaging discussion on the exciting world of digital twins. Thank you very much.